Hello everyone, welcome to another problem session from vector and scalar. In this problem, there are three vectors in an arrangement. They are head-to-tail connection, and they create a resultant vector R. The vector B is 10 meter, which is along to the positive x direction. Vector C is 23 meter, which create a 50 degree with that x-axis, and resultant vector R, which is 35 meter towards the positive x direction. Now we have to find out the vector A magnitude and the direction of vector A. Fine, we can find out the magnitude and the direction of vector A if we can express the vector A in terms of its component, say like that: ax I hat plus ay j hat, right, where ax and ay is the component of vector along to the x direction and along to the y direction, and I hat and j hat actually the unitary vector in the direction of x and y respectively. Fine. Now if I could express that vector A in terms of that way, then I could able to find out the magnitude and the direction of this vector, because in that case the magnitude of that vector would be basically root over ax square and ay square, right, and the angle theta would be tan inverse ay divided by ax. Using these two formula, we can find out the magnitude and the direction of this vector A. Now, they say that these three vectors create a resultant vector R, which is towards the positive x direction. So that's why we can write down, so vector R would be basically vector A plus vector B and vector C. So that means if we can express this vector in terms of unitary vector I and j, we can add them together to find out the resultant vector. Fine, we'll do that. We already expressed the A in terms of this, which is ax I hat. We assume that one because we are going to find out these ax and ay, which is the component of vector along to the x direction and along to the y direction. Fine. Now we can express the vector B. Since the B has a length is a 10 meter and it's towards the positive x direction, so that's why we can express the B in terms of that. Now what about the C? Look at this. To find out the C vector, they give that, say if we choose, this is the axis over here, then the C vector basically, say I am using the different color for the C vector, say that color. So C vector actually towards that direction, right, which create an angle is the 50 degree over here. Now I'm going to extend that vector C, say this is actually that vector C. We can do that. If we do that, then we can say that angle would be also that C. Then it would be easier for me to split that vector, because one component would be towards that direction, which would be the Cx, and another component would be towards that direction, which would be actually that Cy. Clearly from this component, you can find out that the Cx component would be positive x direction and Cy would be towards the negative y direction. Fine. Let's find out that, say, we can write down in that case, C would be, the magnitude of the C is 23. I'll write down the cos 50 degrees, since it's create an angle, the 50 degree over here, and it's a clockwise. If you write down cos of minus 50 degree, that's going to be the cos 50 degree, since cos of minus theta, basically the cos theta. Fine. Now what about this y component? Y component we will find out, says with the minus 23 sine of 50 degree j hat. I'm sorry, I missed the I hat over there, right? It also come from here, because if you use plus 23 sine of minus 50 degree. That's going to give you minus sine 50 degrees. That's a minus sign over here. Now I find out, right? So I can find out, if you simplify this equation, you will find out that C would be 14.78 I hat minus 17.62 j hat. So this is actually the vector C in terms of unit vector. Now I am going to add them together to find out the resultant. Say that vector R. So first I will write down the vector A, which is AX I hat plus AY Z hat. So this is the vector A, plus vector B. B is 10I, plus the vector C. C is 14.78 I hat minus 17.62 j hat equal to the vector R. Vector R is basically the 35 I hat, since it's towards the positive x direction. Now you can do some, we can separate the x and y component. So I'll write down, say that I factor out that, say that I component AX plus 10 plus 14.78. This is actually that I component plus AY minus 17.62 j hat must be equal to 35 I hat. Right, since the vector R has no y component, we can say this will be basically the 0, y component will be the 0. Now we can write, so we can say, now we can say this one would be basically that 35 psi component, and this one is going to be basically the 0, since there are, because we can write this is would be that 0 into j hat, right? So since the vector R has no y component, then we can say, so this is going to be AX plus, this is going to be the 24.78, right, equal to the 35, because I component we separate that one, or AX in that case would be 10.22 meters. So this is going to be that AX component of the vector A. And for the y component we can write, say, AY minus 17.62 equal to the 0. I just write down the coefficient. X component would be that coefficient equal to that one. This component will be this one, since it's a linear equation. So we can separate the coefficient in that way. Fine, in that case, we'll find out this AY would be 17.62 meter, right? So I find out your x and y component separately. Now I can write down the resultant vector. So that vector A, which is actually the AX I hat and AY Z hat, we could write down is with a 10.22 I hat plus 17.62 Z hat. So this is actually that vector. So the magnitude. Now the magnitude of this vector A would be square root of that, right? So we can write down, say, 10.22 square plus 17.62 square. If you do that, you will find out that this magnitude would be 20.36 meter, and the angle theta, which is tan inverse AY by AX, which is actually that tan inverse AY is 17.62 divided by 10.22. So that will give you 59.8 degree. So that should be the answer of this question. So magnitude of A would be 20.36 meter, and the angle that vector A is going to create with that x-axis, positive x-axis, it will be the 59.8. This will be answer of this question. Okay, thank you very much.